Welcome to our talk. We're going to talk about building containers faster with Jib, which is a container image builder we built for Java applications.
So who are we? We're a team based out of New York. We build tools for Java developers targeting the cloud. I'm Appu.
And I'm Q. So cloud deployments nowadays are moving from VMs to containers. Many of you are probably already familiar with containers, which allow you to say, split up your application into microservices and orchestrate these with tools such as Kubernetes. And Java developers are already familiar with building jars. Containers are sort of the same concept. The idea behind Java is very similar to the idea behind containers, which is this idea of write once, run anywhere. However, building containers for Java applications can be quite a confusing and tricky process.
So let's go through an example of a Java developer who's new to containers and trying to figure out how to write a Dockerfile to build a container.
All right, so let's say I'm a Java developer and I'm building a website for a pet clinic. I want to containerize my backend, my Java backend, and I want my container image to be on my registry at ilovejava.io/petclinicapp. So what do I do first? I go and I search build Java Docker image. And I read the top few tutorials, and I'm able to write this Docker file. So I run Docker build, but it takes a very long time to actually do the build.
So some of you may have already written a Docker file like this, but to see what's going on here, you're choosing a base image, you're installing a bunch of things, Python software properties, some other stuff I don't really understand. You have to install Java 8, you have to accept the Oracle license, then you run and install Maven, you put your application on your container, and then you do your build on your container. It's a lot going on. There might be a way to simplify this and remove all the unnecessary runs.
OK, so I read some more tutorials, and I'm able to write this much better Docker file. I'm using a well-maintained base image, the OpenJDK base image off of Docker Hub. And all I'm doing is I'm copying my fat jar into my container image and setting my entry point to run that fat jar. It's a lot simpler, a lot fewer layers.
So this is nice. It's very obvious what's going on here. I understand all the lines. However, when I ran this build, I saw that my image was over 300 megabytes. And I know some people are concerned about disk space. So maybe there's a way to make this smaller.
We're most concerned.
So, OK. So I do some research. I find that the OpenJDK base image is 284 megabytes by itself. And that's huge, making my entire application over 300 megabytes. So I do some more searching. And I find that I can actually use the Alpine version of OpenJDK. Alpine is a tiny Linux distribution, which by itself is only about 4 megabytes, and I'm also only just using a JRE version. So this base image is only 82 megabytes, making my entire image a lot smaller than what I started with. However, it seems that when I run the build, it still takes a while to do the build.
So it's not obvious from here, but when you do a Docker build, the first step is sending the context over to the Docker daemon. And the context is everything you need to build your container. By default, the context is everything in the directory with your Docker file. But in here, you see we only need our pet clinic fat jar. So maybe there's a way we can limit what we send.
OK, so I do some more searching. I find that there's a Dockerfile best practices. And that's a lot of best practices. I see in there's something about a Docker ignore file. So I do some research on Docker ignore files, and I'm able to write this Docker ignore file. It ignores everything in my project directory except for the fat jar that I want to copy into my container image. So now my build runs a lot faster, but so I can now do Docker push and have my image be on my registry. But it seems that even if I just change a single line of code, my push still takes a while. Why is that?
So usually every line in your Docker file creates a new layer, and your image is made of a bunch of layers. In our example, one of our layers is our whole application. So if you change a tiny part of your application, when you build, you have to create that layer again. You have to send it over. If your application's pretty large, then that might take a while. I mean, perhaps there's a way we can split our application into smaller layers.
OK, so I do some more tutorials. and I'm able to write this better Dockerfile. I split up my application into 2 layers, one for my dependency jars and one for my classes files. This way, when I only change my classes files, the only layer that I need to resend when I do a Docker push is my classes layer, and not my usually much larger layer with my dependency jars. So I think I'm good to go, right?
Yeah, except it looks like we still need to run some Maven goals to prepare for our build. You know, that's the problem with having 2 build files, is you have to maintain 2 build files. Maybe there's a way we can do this in Maven?
OK, so I do some more searching, and I find that there's actually Maven plugins I can use to define my Docker build within my Maven POM XML. So I delete my 4 lines of Dockerfile, add this 20 lines of Maven configuration, maybe I'll do my entire build from Maven. Great. I think I'm good to go.
So there's a lot going on here. We wrote a Dockerfile that we found on the internet. We tried to reduce the image size. We tried to reduce how much happened in the Dockerfile. We added a Docker ignore. We tried splitting our application up. We even tried this Spotify Maven plugin, which we're aware is deprecated, but is great for this example. There's other things we didn't cover. You have to download and install Docker. The order of layers in your Dockerfile kind of determines your cache hits. You can use multi-stage builds. There's more Docker cache things to be aware of. And finally, you have to have your Docker daemon running as root. Our colleague Ray has some more Docker tips and tricks if you're interested. It's not the point of our talk, but if you want to take a look, it's at this link here. We're going to show this link again at the end. Yeah.
So when containerizing with Docker, there's many steps that exist between your project and your container image actually being on your registry. You have to build your jar, you have to write your Docker file, you have to send that along with your jar via the Docker client to the Docker daemon, and then the Docker daemon has to run a container or to build your container image and then pushes that container image to the registry. But we're all Java developers. We don't want to have to care about Docker files. The containerization process should be as simple as having your project, running some build, and having your container image just be on your registry. So in our example, we have our pet clinic project. We run some build, and we should just have our container image just exist on our registry. So that's why we built Jib. We built Jib as plugins for Maven or Gradle so that you can containerize your existing Maven or Gradle projects in 2 easy steps. Just apply the plugin and run the build. So now we'll give you guys a demo of how Jib works. So we're using the Spring Pet Clinic project, which is a sample project from the Spring Frameworks projects. And I'm going to go, so right now I have it open up. And I'm going to go into presentation mode so you guys can actually see. So this is the POM XML for the sample Spring Pet Clinic project. Go into the plugins. And I'm going to apply the Jib plugin. I have this set as a live template. So that's just going to apply the Jib plugin. Scroll that up a little bit. So this is just applying the plugin. I'm setting where I want my image to be at once it's containerized. This is just a demo project I've set up on Google Cloud, and I'm using Google Container Registry as my registry. So now I can go into my terminal. This directory was the project. I just do a Maven compile Jib build. And what this is going to do, it's going to run through the normal compilation for that Spring Framework project. And after that compilation finishes, it's going to run the containerization with Jib build. So now it's running Jib build, and it's building a container image. And once that's done, we'll be able to grab the image reference, which is right here. This is the image reference that we set in our configuration. And I'm just going to use Docker to show you guys that we can run this container. So right now, I cleared everything in my Docker images already. And I'm going to do Docker run with that image reference. And I'm going to just expose the port 8080 so that we can hit it from a web browser and see it in action. So this is going to pull that image and run that image. And once this starts, you can see our application is starting up from within the container we just containerized with jib::build. Once that starts up, we'll be able to go to the web browser. and just hit the localhost 8080. And we see our demo peclinic application start up from within the container. All right, great. Let's get back to the presentation.
So in this demo you saw, we did a jib build, which is takes your Java application, puts it in a container on a registry. But some of you still have Docker infrastructure, and maybe you still want to try this with your existing, is it down?
Yeah.
So we have one option to build to a Docker daemon you might have running locally using for tests or whatever. And then we can even generate a Docker context with a Docker file that does the same build that we do in jib, and you can use your Docker build to create an image. In the example, it was all default config, but you can set JVM flags. You can choose your output image format. You can use OCI. We have multiple ways to set your credentials you need for pulling and pushing to private registries. And there's an option to set the program arguments that you pass to your main method. Oh. So we want jib to feel more like a compiler for containers. If you look at a Docker file, it kind of feels like a script. You know, you choose a base image, you run a bunch of arbitrary commands. You can even run your build inside your container for your application, and then you configure the endpoint. But a containerizer that's integrated into your build tool should have enough information to do all of that for you without having to go to a second build. So historically, you know, code's been compiled into an executable, and a containerizer should take your Java application and just build it into a container. And Java, we've been doing this for a while. You take your application and you jar it up into a jar. And with jib, you take your application and you jib it up into a container. So let's go into a little bit of how jib works.
So we kept a few goals in mind when we were developing jib. First, we wanted to have jib be purely in Java so that you can containerize your Java project with nothing but just your Maven or Gradle build systems. We wanted jib to be optimized for Java applications so that you can deploy your changes fast and incrementally. And we wanted jib to be able to build images reproducibly. So we implemented jib completely in Java so that you can build with just your Maven or Gradle build systems. And the benefits of these are that you don't need to install Docker or have the Docker CLI. You don't need to run the Docker daemon. You don't need to have root in order to run that daemon. And you're not actually running a container in order to build a container. So how do we achieve this? Well, first, it helps understand what a container image is. A container image is just a directory of files. And in the Docker image format, this directory of files is split up into layers, each represented as tarballs. And these tarballs compose into the actual file system for the container. And in this format, there's also a container configuration, including things such as environment variables, entry points, volume mounts, exposed ports, things for when you're actually running a container. So this is an example of a container configuration. You have the checksums for layers. And in an example, there's also an entry point set, which is a command that's run when the container image is run. And then in this format, there's also a manifest that just wraps up all the components of the container image, your layers and your container configuration. This is an example of a manifest. You have just IDs of the layers and the configuration as well. These are also checksums. So in the jib image, we build our application layers on top of the distrolist/Java base image. Distrolist is a set of language-focused base images for languages such as Java, Python, Go. And these images don't include anything but just what is necessary to run your application in that language. So compare this to Alpine, for example, which is a popular base image recommended by Docker. Alpine is still a Linux distribution. It's just a tiny Linux distribution. Distrolist, on the other hand, doesn't include package managers, shells, or any other unnecessary programs, but just what is necessary. So this helps to improve security by reducing possible attack surfaces, helps to keep your container image as minimal as possible. This is essentially what a container should be. It should be just your application and its runtime dependencies. So if you guys want to learn more about distrolist, our colleague Matt has a great talk that's linked to in the distrolist repository.
So speed. If we're trying to replace your Docker build, we want to be as fast or faster than what you were previously getting. So the way builds work in Docker is you create a bunch of images. Say in this example, you have a 100 megabyte, say, base layer and a 50 megabyte application. When you push it to a registry, it sends both layers over. However, when you make a change, it only sends a layer that's changed. So let's say we change something in our application, and we do a Docker build and push. This layer is rebuilt and pushed to the registry. And even a possibly better way to do is to split your application even more into, let's say here, 49 and 1. And if we've done it correctly, we're making all our changes during development in this 1 megabyte layer. So our sends are quick, and they send very little over the wire. In Jib, we don't use a Dockerfile, but this is what we think an optimized Dockerfile might look like for a Java application. You see it's split into dependencies, resources, and classes. And then we have an endpoint that ties it all together. But Jib doesn't use a Dockerfile. It still builds like this. So here's a small example of kind of showing you how you get speed improvements. Your first build using Jib or Docker. This Docker is a Dockerfile example that we found on a Spring tutorial. It uses a single layer for your application as opposed to 3 layers like we do in Jib. And your first build is the same. You have to send everything over to the registry. If you rebuild without changes, they're both pretty fast because they just have to go through the motions of deciding nothing's changed. However, when you rebuild with changes to, let's say, just your class files, Jib is only going to resend your classes layer, whereas a traditional Docker build will send your whole application over because that's what you told it to do. And here it's the difference between 5 and, say, 15 seconds. But if you look at a much larger application, down at the bottom, when you change, this one might be heavy on dependencies and resources. So when you change classes, again, Jib is only sending a small layer over, while your traditional Docker build is going to send the whole thing over. And that, in this case, takes 35 seconds, which is a lot of time to be waiting for your build.
So another benefit we get out of a custom image builder like Jib is the ability to build images reproducibly. So what does reproducibility mean? Reproducibility means that the same code always produces the same image. So for example, if you were to make a change and commit that to, say, your Git version control, that commit should produce the same image on your machine as your teammate's machine, your production machine, or your CI/CD system. And what this helps you do is reduce possible variations that could occur in a production container build that you can't reproduce in a local development build. So how do we achieve reproducibility? Well, we just wipe all the metadata that could vary between builds, such as timestamps, user IDs, and groups. So now that we talked a little bit about how Jib works, there's still much more that we can do to improve the containerization experience.
So this is kind of what we're hoping to cover in our next versions of Jib. We can have smarter inferences. We can try and figure out what port you need to expose and do that for you. There's other container optimizations based on your Java application, like how much memory you need or how much CPU you might need. We can try to organize your layers logically based on what code we think is going to change together, so we can hopefully have faster builds there. And then Java modules, they let you reduce the size of your JRE, and we could possibly reduce the size of your container completely. So we've covered the build part, but we're still trying to make it easier for Java developers to get their code running on a container. And our next demo is an experimental plugin we're working on to help during development that'll get your Jib-built image running and available for debugging on Kubernetes.
Yeah, so now I'll give you a demo of the experimental plugin we've been developing for being able to run and debug your Jib-built container on Kubernetes. So just a little bit of context, Kubernetes is a tool for being able to orchestrate your containers across a cluster of machines. And here, before the demo, we already set up a Kubernetes cluster on Google Kubernetes Engine. It's very easy to do. All you need to do is run that one command. So we had that set up. We're going to go into our terminal, and we're going to stop this container from last demo. And so kubectl is the command line interface for interacting with your Kubernetes cluster. Can everyone see this in the back? Is it good? All right. So I'm just going to show that we have an empty Kubernetes cluster set up. So might take a little while. Like every time, first time you run it, might be fetching credentials or something. In the meantime, so we're going to go and apply the experimental plugin we've been developing. So I have this as a live template as well. So what I'm doing is I'm applying this plugin without any configuration. It'll be able to just use the Jib's image. So this is called the Kubernetes Dev Maven plugin for now. Let's go back to terminal. So you can see the cluster is set up with just Kubernetes running. So now what we can do is we can take a project, our Maven project, and do Maven Kubernetes Dev. And we'll do the debug goal for being able to debug our application. And I'm going to expose the port 8080 again. And what this is going to do is it's going to generate the Kubernetes manifests. It's going to deploy those manifests to the Kubernetes cluster. And it's running the application, the container in the application with the debugger agent library and exposing that port and actually forward that port to our computer so that we can debug it in our IDE. So what we can do now is we can go back to our IDE and go into, this might be a little hard to see, but run, edit configurations, and all we're going to do is we're going to add a default remote debugging configuration. So add a default remote, and we're just going to press OK. And now what we can do is we can go to run and just debug that configuration we just made. And now our IDE's debugger is connected to our application that's running in our Kubernetes cluster. So as you can see, the application is starting up. And once this starts up, we can actually hit it from our web browser. But first, let's see what is in the cluster. So as you can see, the Pep Clinic application has started up as a service in the cluster, and it's generated an external IP that we can actually hit live. Anyone can actually hit it in this room. So we can go there. Let's first see if it's started up. It is started up. OK. So let me make this bigger. So as you can see, it's running on our Kubernetes cluster, just like it was running locally in our container. So this is in a container on Kubernetes. So let's say we want to do some debugging. We want to, let's say, just don't show any veterinarians. So what we can do is we can perform a hot swap. So we can go back to our IDE, and let's go to the controller for that page, the /vets.html. And let's just comment out the line that just adds all the veterinarians to the page. We can save that, go to build, recompile. So this will recompile the class, and it will ask us to do the hot swap. So it asks us to reload class. Yes, we'll reload it. And this will swap out the class that's running on Kubernetes. So now if we go back to our page and refresh, we'll see that there's no veterinarians left. Cool. Let's go back to the presentation. All right, so that was a lot of stuff we just did. But what did we just do? We took our project, we ran some Maven plugin, a goal with a Maven plugin, and it put our application in containerized form on Kubernetes for us to be able to debug. And we were able to use our IDE to attach to our running application and debug our application that's running in a remote cluster as if it was a locally running application.
So you saw the tools we built for helping you build, stuff we're working on to help you run and deploy. The future now is we're trying to make Jib available as a library instead of just plugins. So if you're building your own container builder tools, you can use the library underneath and have a lot of it taken care of for you. We want to release the debug and run plugin, possibly using scaffold underneath, if any of you are familiar with that. That's another team at Google that we work with. And finally, we know this is hard, but we want Java developers to be able to run their Java applications on a container cluster without having to know anything about containers.
So Jib is now available in beta, and you can find it at our GitHub repository. And we welcome you to check it out, tweet about us, blog about us, and leave us feedback. And we have quite a few minutes for questions. So let us know if you have any questions. We'll also probably be at the Google booth afterwards. Thanks a lot.
No questions.
Yes?
Yeah.
How do you integrate it to the Maven release cycle?
So the question is, how do you integrate it to the Maven cycle of the life cycle, right? Yeah. So you can actually add it to a phase, lifecycle phase, and just have it execute. So the plugin, you can define executions for the, say, the build goal, and have it execute on the phase that you want it to execute on.
As long as it happens after compile. I mean, presumably you would put it in package, which is where most builders or packagers go, and we're kind of a packaging tool. So,
yeah, and this is also available as a Gradle plugin. So in Gradle, it would be you can set a dependency for the ship task on whichever other tasks you want to run it after. Yes.
What about setting like volume mounts if you need to import something?
Yeah, so currently we don't have a way to define volume mounts that you set that's burned into the image. But if you're running the image on, say, Kubernetes, you can define the volume mounts for the container. Yeah. Yes.
Yeah, so he's asking if it's configurable, if you don't want to use the base image distrolist. Distrolist is just the default we use. There's an option to change where you're pulling your base image from. You can use Alpine or whatever you want. I'm sorry?
JFrog. Yeah, that's you're talking about a Java agent that you want to add, right? Sorry?
Oh, they're a container registry?
Oh, container registry. So the container registries, it should support most like cloud providers for container registries. You can also even use a private registry that you set up yourself. So you can for example, you can even push it to a local registry if you want. So you can run a local registry. You can just have it be like localhost, whatever port, / whatever image. So the first part of that image reference is going to be the registry that you want to push it to. So yeah, whichever other container registry that you want to use, it should be able to do it. If it doesn't, let us know. We'll try to fix it.
It's not built specifically for Google Cloud Registries.
Yeah.
Or Google Container Registry. But you have to set up auth on your own.
In GitHub, it says that limitation is pushing to Azure container registry.
Yeah, there might be some.
So what's the difference?
There might be some credential issues with Azure Container Registry that we haven't figured out yet, but we're still working on that.
All right. All right.
Cool.
Thanks for listening, guys. And girls.